So first I'm going to overview what you have learned so far. We started out with research methods and we went over the scientific method, and we learned that the fifth step is to analyze the data, and to do that you need to do statistics, and there's two types of statistics, two main branches. You learned about descriptive statistics already, and you learned about univariate descriptive statistics and bivariate descriptive statistics. Univariate is one variable at a time, mean, standard deviations, histograms, things like that. Bivariate is the describing the relationship between two variables, so a scatter plot or correlation or a contingency table. And now we're moving on to the inferential statistics phase. And to do that, you had to learn about probability. And we're going to take concepts from the descriptive statistics and the probability and kind of mix it together to do the inferential statistics. And there's going to be two main kinds of inferential statistics. The first is going to be confidence intervals. And confidence intervals are taking a sample statistic like a mean and estimating the population parameter, like the population mean. So you'll say, I think the population mean is between 10 and 15. Now we'll show you how to do that with formulas, etc. But notice how I say it's between two numbers. There's a margin of error of it because we're not 100% sure of our estimate. So we have to put a range on it. And then we have hypothesis testing. So you made hypotheses early on in this course. So you're going to learn how to test them with your sample data. So you have this population of interest, and you want to know if your hypothesis is true or not, but you can't sample everyone in your population. Say your population is the whole United States. You can't sample everyone. You don't have the time, the money, and not everyone's going to want to be in your survey. And so you take a smaller sample of people and get their information, and you're going to use that information to decide if your hypothesis is supported or not. And you're going to calculate what's called a p-value, and we'll get into that. And so this is just the overview. So we have confidence intervals and hypothesis testing. In this class, we're going to focus on what are called parametric tests. Parametric tests have scale outcome variables, and they also have certain assumptions about the central limit theorem. There are non-parametric tests, but we will not cover them in this course. In your book, if you have the book, there's a chi-square test, and that has categorical outcomes. And parametric tests also focus on the mean, and there's also non-parametric tests that have a scale outcome variable but focus on the median and don't have as strong assumptions, and it doesn't have to have the central limit theorem hold true. But we will focus on the parametric test, and these assumptions also hold true for the confidence intervals as in addition to the hypothesis testing. So you need to make sure these things hold true to do the tests that we will talk about. So 1, it needs to be a scale outcome variable, and 2, the central limit theorem needs to hold true. And for the central limit theorem to hold true, hopefully you remember this a little bit. No, it wasn't the most fun topic, but you need to have a normal population distribution, which you might not know what the population distribution looks like because you just have the sample. Or you can say have the sample size to be at least 30 or more. Most of the time you just try to have a high sample because you really don't know what the population distribution looks like unless you look at data from the past, and there's a lot of it, and you can be pretty sure it follows a normal distribution. Anyways, one of those or both have to be true, and then also you need random sampling. Now, random sampling is hardly ever met. Usually we have this big population of interest, a whole country or the whole world. We want to make inferences about people in general, or at least about, people in the United States. If we're from the United States, or if we're a researcher in China, we want to make inferences about people in all of China, and there's a lot of people, right, in both of those countries. So, we don't have access to everyone in the United States, right? I don't have the name of everyone in the United States personally, and they're not gonna all want to talk to me and take my survey or my experiment. And I don't have the time or the money to get a list of everyone and put them in a computer and randomly pick people. I can't do that. And secondly, as I said, not everyone's gonna want to take my survey. They're not gonna want to participate. So you're not gonna have a random sample unless your population is very small. Like, say I want to sample everyone in this class. I want to not sample everyone in this class, but take a random sample of people in this class. That might be possible, right? But your population just is really big. You're really not going to have random sampling usually. But hopefully you have a reasonably unbiased sample, or you can say a representative sample. So if my population of interest is everyone in the United States, and I have a college sample at my local college, that might not be representative. One, those college students are probably going to have an average age that is younger than the average age of the United States, right? There's younger and older people in college, but on average, it's going to be around 20 or something like that. But in the whole United States, that average age is going to be higher. So that's one way it's not representative. And another way is that by definition, people in college are going to have at least a high school degree or its equivalent to it, and they're going to be in college, so they're going to have some college education. Wherein people in the United States, the whole United States, not everyone has that education. So people might be different, and people in the college might have different results in your study than people in general in the United States. Now, it might not matter too much depending on what you're researching, but for some things it might really make a difference. So instead of getting a college sample, you might want to go out in your community and get more diverse sample. Now, every study is not going to be perfect, and every study doesn't have the perfect sample, and so that's okay. Your surveys weren't perfect, but at least you should be able to identify where you might have a bias in your sample or your methods or whatever we talked about in the research methods phase. So nothing's going to be perfect. No study is perfect. That's why we have a bunch of different studies. So don't put too much weight on just one sample and just one hypothesis test or confidence interval, because you never know if it's right or wrong or how your bias sample will affect the results. Okay.